Okay, welcome back. We are doing now rotations, I beg your pardon, reflections. Now, in an exam, you want to be asking for tracing paper. With any transformations, you have a right, by the way, in an exam to ask for tracing paper, and they can be a lot easier with tracing paper. I'd rather, to be honest, with reflections, you don't use tracing paper, but it's still really useful to get an idea beforehand or to check your answer. So I would definitely use it, but if you understand the principles of reflection, you're going to go a long way. So we've got an object here, A, and we're reflecting it in different lines, okay? So the first question is reflect in the line I don't really want to reflect it in x equals -2. Y equals -1. Well, it's still there to show you where the line is. So these lines might be weird to you, but y equals -1. If you think about this line that goes along here, the coordinates of all these points, the y coordinate is always -1. So if you look over here, this is -4, -1. If you look here, this is -1, -1. If you look here, this is 3, -1. So the x coordinate changes all the way along that line, of course, because it's going left to right or right to left. But the y coordinate stays the same. So this is the line y equals -1. You do want to learn those because in the exam, they'll often not draw the mirror line or the line of reflection. They tell you reflect it in the line y equals -1 like this question. So the line is drawn here for you and it's the green line. So the principles are, again, that you always reflect each vertex. Don't try and reflect the shape, reflect the vertex. Now, what you need to do, let's use green because the mirror line now, that might be confusing, is you want to think of a perpendicular angle to the line of reflection. So this is horizontal, perpendicular means right angles. So perpendicular is vertical. So I want to go from here, this corner, this vertex, to the mirror line at a perpendicular angle, which is fortunate on the first one because it's straight down. So I go there and I've gone 1, 2 squares to the mirror line, and I go another 1, 2 to there. Okay, so I've gone 2 squares up to the mirror line and 2 squares past it. So that corner is transformed to there. Now with all the other ones, translation, fine, draw the rest of the shape. With all the other transformations, did I say transformation? I meant translation. Translation, you can draw one corner and then fill in the rest. Don't do that with anything else because you'll get confused because it's going to flip. So that's the first corner. So I'm going to then do this corner. Down 2, down another 2, there. Then I'm going to do this corner. So 1, 2, 3, 4, 1, 2, 3, 4. And then you can see with the last corner, this one is going to go down here. Okay. So you need to remember perpendicular at right angles to the line of reflection. And that will seem obvious when it's horizontal or vertical. I think it's, you know, it's going to be reflected down here. Now this is where the tracing paper is really useful. You can put the tracing paper over the whole thing, draw the dotted line, hold the tracing paper still, draw the dotted line, draw the object, and then just fold along the dotted line, and you'll see that it overlaps here. If you remember in primary school where you get a piece of paper, fold it in half, well, so you paint half of a butterfly on one side, and then you fold it, it sticks, it sort of copies, transfers the paint across the other side, and you've got a butterfly. So it's a bit like that, you fold it in half. And so we can label that a apostrophe. Now I would do x equals, reflecting the line x equals -2, but as you can see, we're going to go 5 squares across here and then another 5 squares somewhere over here. So it would look rather like that. But it's right off the page, so that's a bit of a nuisance. But we will do, this line is y equals -x. Now if you're going up here at 45 degrees, then that is the line y equals x, because anywhere along that line, the y coordinate is the same as the x coordinate. So you'd have -4, -4, -3, -3, -1, -1, 1, 1, 2, 2, 3, 3, 4, 4, etc. This whatever the y coordinate is, the x coordinate is negative. So if the y is positive, so 2, the x is negative 2. If the y is positive 4, the x is negative 4. And vice versa. If the y is negative 1, the x is 1. Y is negative 3, x is positive 3. Okay, so that's the line y equals negative x. So this is when we need to stick to our principles. So reflect A in the line y equals minus x. So perpendicular to a diagonal. Now this is 45 degrees. I say it's 45 degrees. If the scale on the y is different to the scale on the x, it might not be 45 degrees, but for this example, it certainly is. So perpendicular is going to be, so you notice this goes diagonally across each square. Perpendicular will be diagonally the other way. Okay, so I'm going to start from a corner. Let's use the same corners I've done, the one highlighted in red. I'm going to go diagonally across to the line of reflection. And then I might count now rather than counting. So it's 1, 2, 2.5. Okay, not quite 2.5 squares because you're going diagonally, but we don't worry about that. 1, 2, 2.5. So I go half, 1, 2. So that red vertex has reflected to there, and it's really useful if you turn your head up so that the line of reflection is now vertical. You can see that that's a nice reflection. I'm then going to do this one. So this is, whoa, sorry, put my head back. This is just 2 squares across to the line of reflection. So it's 2 squares across here. So it goes there. You can then do this one. That's 3 squares. 1, 2, 3. Still at 45 degrees. Still perpendicular at right angles to the line of reflection. And then I can go 1, 2, 3. And then, yeah, when you've got 3 vertices in, the chances are you can fill in the 4th. But better be safe than sorry. Whoa. 1, 2, 3.5. So I'll go half, and then I'll go 1, 2, 3. And sure enough, that's where I thought it was. That's a relief. So you imagine the amount of time it takes you to do that last vertex. I wouldn't ever guess. Just reflect all 4 corners. But look how different it is. And we'll call this A apostrophe twice. We don't want it being the same as this one. And it'll probably say label it B or something, but you just follow the instructions. But if you look, that may well not have been where you expected. Either where you expected or the orientation, meaning which way up it is. But if you turn your head to the side or turn the paper to the side, you can see that each corner, ignore the shape, each corner is reflected the same distance the other side of the line of reflection at right angles to the line of reflection or the mirror line. Okay, and we could reflect in x equals minus 2. As I said, it's somewhere over here. This has gone up a little bit because it adjusted, but that's the basics. So you want to go equal distance. So the object, each vertex of the object will be the same distance from the line of reflection as the vertex of the image. And when you're tracing across to the line of reflection and the other side, it needs to be at right angles to the line of reflection. The way I would suggest, there's 2 ways of doing it. If they've given you the reflection, say find the line of reflection, that can be quite a tricky question. Possibly the best way to do it is to use that tracing paper. Draw the shape and then just keep trying to fold it in different places and see where it folds so that it overlaps. But that's the basics of how to reflect a shape. I know that's a bit of a rush. I hope it made sense. Well done for listening.